Hello and welcome back. My name is Amir and today I'm going to solve the puzzle on day 7 of Advent of Code 2022. Well, as you can see here, I have already received my stars, meaning that I have already solved the problem. Because this was a more advanced one comparing to the rest of the ones that we have already solved together. So I didn't want you to sit around and watch me try to solve the problem, which would take like more of your time. However, I thought about presenting the code in JavaScript to you and guide you through the thought process that I had through the solving the problem. So let's get to it then. So our input here is the output of a terminal like this, and basically it has two commands that is being used throughout this terminal. One is the cd and one is the ls. Cd means change directory to something that comes after the cd, and ls means list the files and folders that are inside the current directory. So in a nutshell, when we say cd slash, we change directory to root, and then we say ls, which means list the files that are in the root, which provides us two directories and in the two files in the root folder. Then we can change to directory A because directory A is inside directory root, and then we get the file systems on the folder A that are these ones, another directory and three files inside it. So this will be changed to something like this. And we need to find the directories that, including their subdirectories, are taking up to 100,000 and no more. So yeah, that's pretty much it. And then let's see the code then. So I have defined two variables, path and tree. Path is keeping the current folder structure. So something like this means that I am in subdirectory E, which is a part of directory A, which is part of the root directory. So this will help me along the way. The other one is the tree. Tree is the tree structure of the folder system. Basically, this is an object or a dictionary as in other languages. It makes no difference. It has a key and a value. The key is the folder name, and the value is the list of the subfolders that are inside that folder. I might use folder and directory in this puzzle interchangeably, so no worries. If I say directory or folder, they are the same thing. Okay, so first things first. So first of all, I will read the input here. It's an UTF-8 format, and when I get the data, I will split it based on $sign. This will give me blocks of instructions. So it will give me this, then it will give me this, then it will give me this and this. So basically the instruction that I sent and the result that I get back. This is what this split does for me. Then I will filter the empty strings that might occur. So for example, when I split it here and this is gone away, I will get an empty string at first, which I don't want. So using this filter, I can remove those empty strings as well. Then I will map them to a read block, which is a function that reads each block of the code. So like this and like this. So let's get to the read block and see what do we have there. Here in the read block function, which is fairly big, I should say, I can first log for you the blocks that we get. So as you can see, these are the blocks that we get, just like the things that we have here in the input. So this is ls with a bunch of outputs, and then we change to cda, which has no output, of course. And then there is another ls, and then there is another ls, which is a command and it has a bunch of outputs like this, and so forth and so on. Okay, so after that I will split each block into different lines so that I can have each of these as a separate line. So if I say if I have it here like this and I keep track of lines, you will see that it will give me a very nice array of the line, which the first one is the instruction or the command, and the rest of them are the list of the outputs that I get. Awesome. So as you see, I have command here as the lines on number 0, which is this one, and the rest of them are from here to here, or here basically. So if the command starts with cd, which means that there is a change directory going to take place, like in here, the thing that we should do is change to that directory that is being provided here, and then it's fine. So if the command ends with 2 dot, we need to pop from the list of paths. So we have been here, and when we say cd, like for example here, then we pop out of E, and then we get back to A, which is the parent directory. So this is what happens here. Pretty simple. And else, if we are in a directory and we have given another instruction, like for example cd slash or cda, then we are changing to a directory. So we need to add that directory, add that subdirectory to list of our directories. So this is pretty standard, nothing fancy, nothing strange about this. But the thing is that if the command is not cd, then it's ls. So we are getting a list of directories and files. So we need to do a bunch of things. First of all, I will define a variable called size, which will keep the size of the files that are inside that folder. And for each line on the rest, which is for example this one and this one and this one, I have two conditions. Either the line starts with a dir name, which is a directory, or it's just starting with a number, which is a file. So if it's a file, I just add the number provided here to the size, and that's done. But if there is a directory, first I need to get the directory name, which is done here. Then I will provide a path by joining the paths together, as we have here, and then push that path to this tree here. So in the end, if I log the path for you, you will see that we have something like this: slash and a slash and a and e slash and d. So this is the path that we have here. And if we log tree as well, you will see that tree is, so forget about these lines and see it here. We only have subdirectory of the root, and then two subdirectory inside that A and D. And then as we go along, if our tree is not created, is created beforehand, and it has like some subdirectories, then just push the size to the end of that. Otherwise, if that directory does not have any subdirectory, which is this case, just create a empty array for that and add the size to it. So this will be something like this, as you can see here. So for example, here directory slash has these subdirectories and subdirectory A has these subdirectories, and this is the file size of the files that are inside the A directory. Okay, so this is basically what is our tree structure. And then we have when this is done and we have created our tree structure, then this is the kinda complicated part. We need to get the keys on the tree, which will be this in the end. Our tree will be this in the end. If I log it here, tree, it will be much more visible. Yes. So our tree is something like this. We have folder A, which has this subfolder and this size. We have folder A, which is inside the root folder. Did I say folder A here? I meant root folder. So we have folder A here, which is part of the root folder, and it has one subdirectory and the file size inside it, and so forth and so on. Okay, so this is our tree. Then the thing is, based on each of these subfolders that we have here, we need to find out what is the file size for this. So for example, for this we need to add this value plus the file size that this folder has plus the file size that this folder has, but we don't have the value for this, so we should come here, and to get the value for this we need the value for this plus this, and we don't have this, so we should come here, get this value, put it here, add it to this, and get the A here, and then do the same for D. So it's kind of a recursive function. So how did I resolve that? I get the keys that are these, then map them to a directory size, which is a recursive function like this. It takes an item, and if tree of that item doesn't exist, or for some reason the value is 0, like it's a empty subdirectory, the value is 0, we just return 0. We don't care about that. If the tree item.length is 1, so in cases like this, when the tree has only files inside and it doesn't have any subdirectories, we just return that value. That value is the value for the folder size. Otherwise, in cases like these two cases, what happens is that we take that tree item and then they filter out this value because we know what is inside. We just want to recursively call the values for these two subdirectories, and then get the directory size for these values, and then finally add them together. So this sub size will give us at the end the value for file size for these two, and then we can have the sub size and add it to this value, which will give us the value for the root folder or for A folder, and so forth and so on. So by this, calling this directory size function, we get the directory size here. So if I log total here, I mean if I comment out these two lines, you will see that our final result is like this. I have four folders with different file sizes inside them. So then what should we do then? Then we should filter out those values that are less than 100,000 as asked here, and then add together and then return the value. So that's pretty much it for part 1. And for part 2, which is usually much more simpler than puzzle 1, we have been given another instruction. So they say that the file system will provide us 70 million available space, and for our update we need 30 million available space. So we need to figure out how much space are we using right now. So probably something around that value, and then subtract this value from this value to get how much space we currently have on the system, which is something in this size. So we are missing like 838,000 or 8,300,000 something. We need to free up this much space from our directory, so we should look through our directory and find the one that is bigger than this value but closer to this value. So we don't want to delete the biggest directory that we have on the system. We want to delete the smallest directory that is bigger than this value. So here what I did was I just get the free space, which is 70 million, and then minus size 0. The size is 0 from getting these from this function will give me the size for the root directory or slash directory root directory. Then the required space is the 30 million that we want minus free space, the required space that we need to empty up. And then the smallest thing that we could find, smallest folder that we could find, is that we should get the size and filter those that are bigger than the required. So those we should remove the smallest ones, and then sort them based on which one is smaller among them all, and then get the smallest value. So this is pretty straightforward, nothing so fancy in this part of the puzzle. I hope you liked my walk throughout the code, and see you tomorrow then.